Welcome to the Imperial Truth. I'm your host, Eric, and this weekend is the second annual Warhammer Conference. The first conference happened last year and was heralded as the first sort of sci-fi academic paper conference of its kind, or the first one at least for a Games Workshop type universe building and IP. And I was really excited about last year's conference. I submitted this presentation that I'm going to do for you today to that conference, and unfortunately was not accepted. And in hindsight, and given the offerings that they have this year, it's pretty clear that they are focusing very much on the social science side of things. I don't think that there were very many STEM-themed talks last year, and looking through their schedule, it doesn't look like there's any STEM-themed talks this year, and that's not, that's neither positive or negative. I'm not weighing in on my opinions of that. It's their conference. They can do whatever they want. For my part, though, I enjoy the science side of sci-fi. And so I'm going to share a little bit of that with you today. I hope that you enjoy it. Consider this sort of the prequel episode to a longer series that will come about later called Forging a Narrative. And in Forging a Narrative, we'll talk about narrative play and how to build narrative lists and theme your armies narratively, but also how to build a campaign, how to build worlds, and we'll kind of dip into a little bit of my background in academia to accomplish some of that stuff. But with that said, let's talk about this specific topic today, which is monobiome planets. Are they lazy writing, or are they a geologic reality? So when we talk about monobiome planets, we're talking about planets that are dominated by one specific biome, say a desert or glaciers and ice, or volcanoes or forests. And these are pretty common among science fiction. In Dune, we have Caladan, which is the House Atreides homeworld, which I believe is an ocean world, and Arrakis, for which Dune is named, which is a desert world. Star Wars has a number of these, from Tatooine, which is a desert world, to Hoth, which is an ice moon. And in the Warhammer 40,000 / Horus Heresy universe, we have a lot of similar planets. And the questions that we're going to try to ask today are, firstly, are monobiome planets even realistic? Is this something that could exist in the universe? What insights can we get, if any, from Earth's history and in the field of exogeology? So Earth's history is pretty much the only planet we really know the geologic history of, because it's the one we've explored the most. And exogeology is this field in which we sort of try to understand how planets form and what sort of planets might be out there. And lastly, can we create realistic functioning worlds how can we create realistic and functional worlds in science fiction setting? So basically, are the authors correct to use monobiome worlds? And we're going to use a lot of Earth's history to sort of extrapolate this stuff. And we're going to look at some examples in the Warhammer 40,000 Horus Heresy world. So we'll start simple. We're going to start with Nocturne, which is the home planet of the Primarch Vulcan, and the home planet of the Salamanders chapter or legion, depending on what era you're dealing with. And Nocturne is a death world. It's dominated by volcanoes and huge earthquakes. And the reason given for the huge earthquakes is its proximity to its moon of Prometheus, which is a very large moon with regard to the size of the planet. Now, we need to understand that at any point in Earth's history, we can grab sort of a snapshot of time. And when we're talking about geologic ages, we're often talking about time periods that are much, much larger than even the 10,000 years of the kind of War Machine hordes. Wrong game system. Warhammer 40,000 / Horus Heresy universe. So during the Hadean Eon, which was our first eon in Earth's history, it's about 4,600 million years to about 4,000 million years ago. So about a 600 million year period. And if we want to kind of put that in perspective, 600 million years of recent history takes us back to just before things like jellyfish and sponges evolved. So all of multicellular life on Earth has occurred in less than 600 million years. And this one specific geologic eon that we're talking about right now is as long as that, right? So during the Hadean eon, Earth was a hellish volcanic world, just like Nocturne. In fact, the term Hadean comes from the Greek Hades, which is the god of the underworld, a reference to this world. And this is an artist's rendition, of course, but this is our Earth 4,600 million years ago. We have massive volcanism covering the planet. Our crust is very young during the Hadean, and in fact originates from the Hadean. So we have kind of constant upheaval, constant volcanism happening. The atmosphere is incredibly dense and choked with volcanic debris and carbon dioxide. And as a result of this, we have these massive lightning storms. The solar system is pretty young, so we have constant bombardment by asteroids during this time. It is, for all intents and purposes, a pretty hellish environment. Towards the end of the Hadean, things do cool off a bit. The transition from the Hadean to the Archean, so the end of the Hadean, is when life evolves. So clearly, life can be sustained on a planet like this at the end of this time period, and we can see that this looks like an alien planet. It looks like something that is not Earth, and could indeed be considered a death world. But again, this is just an artist's rendition of Earth, not a planet somewhere else in our galaxy. So during Earth's formation, our moon was probably formed by this planetary collision with Theia. I would say it's pretty certain, but it's not definitively proven. There are some things that we will talk about later, not in this specific presentation, but later in the series, that point to this collision. But basically, Earth has a lot more iron on our planet, and a lot more radioactive elements on our planet than we probably should. In addition, our moon is very large, considering the size of Earth. If we think about a planet like Mars, Deimos and Phobos, the moons of Mars, are asteroid captures. So they fell close enough to Mars to get captured in its gravity well. Our moon did not form that way. Our moon is constantly moving away from us. It's like I said, it's not an asteroid. It does seem to have originated from Earth's crust. And the most likely way that this could have happened would be a collision with a different planet. And that collision would combine sort of the denser elements in the centers of the planets, while blasting the lighter elements into space, which would then form the moon. And the result of this on Earth is that Earth has, like I said, an exceptionally large moon, and we are very tectonically active. Those radioactive elements in the mantle, as they decay, they release a lot of heat energy, and that heat energy drives volcanism on our planet, and is one of the reasons why we can even have life on Earth at all. So if Nocturne was a similar system where we had two planets collide, and maybe the planets were both larger or one of the planets was larger, that could result in an exceptionally large moon, just like we have, maybe even a larger moon if the collision was at a different angle or with different sized planets. And in addition, that extra radioactive material that would get dumped into the planet of Nocturne would drive additional volcanism. So a lot like Hadean Earth, where we have this kind of hellish environment, constant volcanoes, Nocturne could just be early in its life and just radioactively very enriched from a planetary collision, not unlike Earth. If we go to the other side of the spectrum, something like Fenris, which is the home planet of Leman Russ and the Space Wolves, my least favorite chapter and Legion. This is a death world that's dominated by huge mountains and super cold icy seas. And again, we only have to go as far as Earth's history to see a similar situation. So during Proterozoic eon, so this is a period from about 2,500 million years to about 541 million years ago, The earliest life on Earth, the photosynthesizers that were here, they were so good at photosynthesis that they basically drained the atmosphere of carbon dioxide, which is greenhouse gas. This, we think, led to at least 3 snowball Earth events. Snowball Earth event is where the entire planet freezes over in a glacial event. And these snowball Earth events lasted for tens of millions of years. So any one snowball Earth event lasted about 1,000 times longer than the 10,000 years between the Horus Heresy and the current 40K setting. So Fenris slots very nicely into this. On Earth, radioactive elements in our mantle bring us out of snowball Earth through plate tectonics. Basically, we can't stop the volcanism, and the volcanism dumps carbon dioxide into our atmosphere, which raises the temperature and brings us out of the snowball Earth event. This is, again, an artist's rendition of our Earth as a snowball Earth event, and it's an icy death world, right? The entire planet is covered in ice. And the blue that you're seeing, that kind of open area, those are brine oceans. So those are oceans that have become so salty due to the formation of ice that they literally can't freeze. And so they do retain some ice in the system. Fenris, interestingly, has this volcano called the Fire Breather, which is apparently a stationary volcano. Like there's not a lot of information about these, but from what I can tell, it hasn't gone away. And so maybe Fenris is a little bit more like Mars, where we don't have a lot of tectonic motion and not a lot of tectonic activity. And so we have the stationary volcano. That would work really well for our system, because if we lack conventional plate tectonics, or at least tectonics like we would expect on Earth, that would prevent their volcanism from driving them out of their frozen situation, right, with their snowball Earth. And I understand that there's some other things about the illumination of Fenris's sun and their distance and things like that. And for the purpose of this discussion, we're just pretending if we can create these worlds, right, without sort of manipulating orbits and things like that. The other side of this is the subduction problem. So subduction is this downward or sideways motion of one piece of crust under the other. So if you think about like the west coast of South America or the Japanese islands, there's big pieces of crust that are being shoved down into the mantle. And that crust has been at the bottom of the ocean for a long time. And one of the things that it picks up during that time is a lot of carbon. Fish poop and die and things fall to the bottom. And that carbon accumulates in the oceanic crust. And as it becomes subducted, as it gets shoved down in the mantle, that carbon gets released as carbon dioxide in volcanism. If we have a system like we do, we're proposing for Fenris, where they don't have a lot of tectonics and they don't have subduction, then they wouldn't be moving carbon from the surface or the bottoms of their oceans into what would be their mantle. And so their volcanoes would be erupting essentially carbon dioxide poor gases. So there wouldn't be a lot of carbon dioxide re-entering the atmosphere, which again would lead to this cold, frozen climate. And they wouldn't be able to bring themselves out of it like Earth did. So we can definitely make a Fenris style planet. Again, just using sort of Earth as our analogy. Medusa, the homeworld of the Iron Hands and Ferris Manus, is again a cold world, but in Medusa, we have lots and lots of tectonics and volcanism and geysers and lots of mountaintops. In fact, on Fenris, on Medusa, they call out the fact that the mountains just disappear, or oceans just disappear because the tectonics are so fast. And on Earth during the Proterozoic eon, that same time period that we just talked about, plate tectonics were basically fighting with snowball Earth to create this planet of fire and ice, where we'd have the fire and energy of plate tectonics driving us out of frozen events, and then life driving us back into those frozen events. Well, one of the consequences of this process is that while volcanoes are producing CO2, at least on Earth, which is a greenhouse gas and warms the planets, the release of sulfur and volcanic debris has a cooling effect on planets. And we can see this if we look at just volcanic eruptions recently. So these are volcanic eruptions that have happened over the last 200 years or so. And we can see that at Pinatubo and Krakatoa, we have these pulses where the temperature on the planet drops precipitously and suddenly. And in fact, Tambora, which happened in 1815, led to 1816 being such a cold year that in North America, we had frozen rivers in August in places like Pennsylvania and New York, which is just unheard of. It was an exceptionally cold year that led to lots and lots of deaths. And there's a great book called Tambora by Dealinda R.C. Wood, I believe. If you're interested, it was really a catastrophic moment. And we can take this one step further and sort of turn this up to 11 in that we have these large igneous province eruptions, or these flood basalt events that happen across Earth periodically, where we have lots and lots of volcanism over millions of years. And this can absolutely collapse our planet in terms of temperature, because of the amounts of sulfur and debris that gets erupted. So the Siberian traps here we think led to the worst mass extinction in the history of our planet, and actually for a little while led to almost a complete cessation of photosynthesis on Earth. And so if Medusa was locked in some sort of perpetual eruption of volcanic material because of excess plate tectonics, we could very easily have a planet where we have lots of volcanism and lots of heat sort of towards the surface as the crust is never really cooling like we would see on Earth. But then the atmosphere of the planet is very, very cold because we just have no real solar input to warm the air and the water. So we could definitely end up with a situation where we have this sort of weird juxtaposition between excessive plate tectonics and our atmosphere. And the other interesting side of this is that when we emit sulfur as a gas, while it cools the land, the oceans actually retain a lot of warmth. So in that Tambora eruption in 1815, in 1816, the land where people live got really cold, but the oceans warmed up, and we actually saw a massive thawing in the Arctic. And in fact, I'm kind of going down a rabbit hole, but in the book Frankenstein by Mary Shelley, which was written as a direct result of Tambora, the end of that book, spoilers, the monster goes looking for Dr. Frankenstein. Where? In the Arctic. Why in the Arctic? Because that's where all the scientists have gone, because the Arctic has melted due to this volcanic eruption. So we could have this situation in Medusa where we have relatively warm liquid oceans, frozen ice in the mountains, just like we saw in say Switzerland during Tambora, and lots of tectonic activity on the planet in general. This is completely reasonable. We're going to take a step away from our Primarch homeworlds for a moment and talk about Ithaca, which is the homeworld of the iron snakes. And it's an ocean planet. It's described as having really deep waters, some tropical islands, and some massive tsunamis. And this is super easy. This is a slam dunk for us because oceans cover 70% of Earth, and they cover 70% of Earth at a depth of about 4,000 meters. If we just smoothed all of Earth's crust out to be the same thickness, and on Earth, I'll show you an image in a moment, we have very thick continental crust, or the cratons, it's where people live, and very thin oceanic crust, which is what underlies our oceans. But if we made all that sort of even and didn't have that differential in crust, Earth's oceans would be about 2,800 meters, which is still a relatively deep ocean. So the idea of having an entire planet like Ithaca that is just an ocean world is completely a reasonable thing. So this is sort of cross section of our crust. The oceanic crust is pretty thin. It's only about 5 to 10 kilometers thick. The continental crust is a bit thicker, and it really depends on where you're at, because obviously it's very thick at the Himalayas, but very thin near the continental boundaries. But you can estimate about 30 to 35 kilometers thick. And because of this difference in thickness, we end up with this topography where, as my physical geography professor like to say, water flows downhill. And so the water accumulates over the oceanic crust. But if we sort of planed all this out, if we kind of, for lack of a better term, Ullanored all of this, we could create a system where we still had almost 3 kilometers of ocean over everything, and that would essentially give us an ocean world. The last of our planets that we're going to talk about is the idea of a forest planet. So Caliban is a death world. It's the home of the Dark Angels, legion or chapter, depending on when you're talking about it, and the home of the Primarch Lionel Johnson. And again, this is a pretty easy one for us to grab. So during the Carboniferous period, which is about 359 to about 299 million years ago, on Earth, plants were incredibly dominant. And they were dominant because, in part, I mean, conditions were perfect for plant growth then, but there were no big grazers, big vertebrate grazers evolved much later. And so there was nothing really to eat these plants. And so they just became massive and dominant over the entire planet, to the point where pretty much all the coal we mine today is from our Carboniferous period on Earth. In fact, even the animals that are present on the Carboniferous were pretty monstrous, just like on Caliban. So here we have sort of a millipede that is, they're about 2 meters long, which are just huge because the atmosphere was supportive of them. Dragonflies were the size of hawks and things like that. So we even get fauna in the system that is very similar to what we would see on Caliban. And if we're talking about sort of astrobiology and projecting what we might find on other planets, one of the things that we can use is this idea of convergent evolution, that life will settle on certain designs or schemes or strategies repeatedly because they work. And on Earth, at least 3 times we've evolved essentially what is a tree, which is, a large, woody trunk made of lignin and cellulose, that is, durable and stable and transports fluids up and down. That's evolved 3 different times. Even if we just think about like pine trees or conifers versus angiosperm trees. So our, your fruiting trees, if you will, your flowering trees. Those are 2 very distinct lineages. They're not derived from each other. They evolved independently. They just settled on basically the same scheme to survive. So it's very reasonable that if we had another planet and photosynthesis was a thing on that planet, that the trees would almost always end up being an evolutionary strategy for things to survive. And if we capture our planet during this snapshot of a Carboniferous, so if Caliban is in its version of the Carboniferous, or was in, it's not around anymore, um, uh, uh, it would have been dominated by trees and probably lacked large herbivorous animals, which again, kind of plays into that everything here is a predator or death world idea. So in conclusion, I would say that monobiome planets are not only realistic, but probably expected and maybe even the norm for our exoplanets. If we just look as far as Mars, which is the image that's in the screen right now, Mars is very much a monobiome planet, and it's been a monobiome planet for a long time. Even during Earth's history, we have periods of tens to hundreds of millions of years where we are locked in a single biome. And if we take a snapshot of any one of those times, we would consider Earth a monobiome planet. When we think about the time period that we're talking about, right? If we think about something lasting for 10 million years or 100 million years, it's important to consider that the 10,000 years between the 31st and the 41st millennium is about 0.01 million years. So this is a very, very short time period geologically, where we're kind of representing this story that we know and love. And so maybe it's a result of lazy writing. It is definitely easier to write a monobiome planet, but it doesn't make it incorrect. And that's what's really important for us. And if we modify just a little bit of Earth's parameters to create Earth analogous planets, we can justify some pretty accurate monobiome planets in our system. So I think it's completely reasonable. I think if you should not shy away from writing monobiome planets, it's definitely a possibility. And like I said, in our Forging a Narrative series in the future, we will come back and we will talk about how to build a planet, how to build a solar system, and even what could be interesting if you want to create your own solar system or planet for a campaign. What might be justifications for that place being so important that it's worth having a fight on? So that's it for today. Thank you very much. If you enjoyed this, do all the things like subscribe, share it with friends, appease the machine god, so that the algorithm benefits us. But yeah, I'll catch you in the next video, and have a good day.